The ACN family of drives does not have a built-in PLC. It does have something called user sequences. And while it's not a full-blown PLC, it does give you the ability to customize the operation of the drive. Suppose you need the drive to run a motor periodically, but you don't really want the hassle or expense of adding a PLC or another controller. Or suppose you need custom acceleration and deceleration ramps that are a function of motor speed. Or suppose you need to count events and shut the motor down when you get too many. User sequences are ideal for small applications like this, and the best way to learn is to jump right in and do some examples. Here we go. You can do this from the keypad, but that's really hard. So we're going to use the VFD Suite software, which you can download for free at automationdirect.com. Just search for VFD Suite, download it, install it. There's a whole video that shows you how to get started with the VFD Suite. If you're not familiar with it, please watch that video before doing this one. It'll get you up to speed quickly. Now, if you aren't familiar with the drive, then check out the ACN Drive Quick Start videos. I'll create a new project, give it a name, skip naming the drive, and hit OK. Connect to the drive. I got my green bar, and it says we're online and ready to go. Perfect. Let's go to the drive parameter group, parameter 93, and use it to reset all parameters to default values so you know exactly where I'm starting from. Read all the drive parameters. I'll speed up the video so we don't have to wait for that. Let's go to the main parameter group and change the ramps to something faster so we don't have to wait on the motor during the video. The motor I'm using matches the default motor parameters, so we don't need to change any of those. Okay, that's enough to get us started. Double-click on the user sequence and open up the user sequence parameters. We'll be using these two at the same time, so I prefer to drag the parameters tab over here to create a side-by-side view. Now, your first step should always be to look to see if the user sequence is currently running. The drive says the user sequence isn't running, so we're good to go. Now, that's important because you can't make any changes if the sequence is running on the drive. These blocks are numbered and are executed in numerical order. I'll widen this up so we can see all of them. You can also hold down the Control key and scroll your mouse button to change the scale of this diagram. When you first start, they're all no-ops, for no operation. For our first example, let's use the timer function to ramp up the commanded frequency in 2 Hz increments once a second to 10 Hz, and then repeat. Picture it like this. The timer is really just a counter. You specify the value you want it to count to, and enable, which is active low, and the mode. The timer can output the timer count or a blip each time the counter overflows back to 0. We want to send the count directly to the command frequency, so we want mode 1. So I'll double-click on this guy, change it to a timer, and write it to the drive. If I open the user function parameters, you can see block 1's function is a timer. I'll right-click on the timer to configure the A input. That can come from any parameter group. We need a constant value, so we'll go to the user sequencer parameters, which are just a bunch of empty memory locations. And let's grab parameter 1. The void just reminds you it's generic. It has no units or assigned type. Write that to the drive. Now, this early version of the software was a bit quirky. Notice that it didn't appear over here. If I go away and come back, there it is. So this is the code you would enter via the keypad if you were doing this manually. That's drive 1, parameter group D, parameter 1F hex, which is 31 decimal. Yeah, now you know why we're using the VFD Suite. Doing this by hand is painful. Right-click, configure input B. Again, we'll use the user parameters, and we'll use parameter 2. Write it to the drive. Right-click, configure parameter C. Grab user parameter 3. Write that to the drive. Right-click one more time to configure the output. We want to send a timer's count to the drives group, command frequency. I'll refresh the function screen by going away and coming back, and yep, we see we're using a timer, and these are all the codes for the inputs for this block that we would normally have to enter via the keypad ourselves for these parameters. I sure am glad the VFD Suite is doing that for me. The output parameter is read-only. It's where you can see what the block is sending out. Okay, now we just need to assign values to these inputs. We can always see the current values in the user sequence parameters here, but look at this. If I right-click and select Value Display, I can quickly see what all these parameters are currently set to. Input A is our max count. We want that to go to 10 Hz, so that needs to be 1000 because there's 2 implied decimal places. How did I know that? Well, go back to the drive parameters, and we see the command frequency requires 2 decimal places. The jog decel time, for example, only requires 1 decimal place. And let's go back to the user parameters. The second parameters are enable, which is active low, so we need a 0 for that one. And we want mode 1, where the timer outputs the actual count. So I'll double-click on the first parameter and set it to 1000 and write it out. Right arrow to the second parameter and enter a 0 and write that out. Right arrow to the next parameter and enter a 1 and write that out. If I refresh the display to update the displayed values, yep, exactly what we need. Let's flip that back to display the parameters. Finally, we see the rate these blocks will be executed is every 20 milliseconds. So since the timer output is tied directly to the command frequency, we should see the command frequency ramp up to 10 Hz, reset to 0, and start over. To run it, we just double-click on the sequencer control, set it to run, and write it out. And sure enough, the command frequency is incrementing to 10 Hz at a 20 millisecond rate. And if we wait a few seconds, yep, it wrapped back to 0. Perfect. And don't forget, you can also see that in the detail information section. I'll select the command frequency and change the scale. Yep, there it is. And you can also view it on a trend graph. You can learn more about both of those in these videos. Notice that we're controlling the drive's commanded frequency regardless of how the drive is configured. If we go to the drive parameters group, we see the frequency source in this drive is set to keypad. So why is the drive allowing the user sequencer to change the frequency? Well, in most drives with built-in controllers or PLCs, you'll find that in general, whenever there's a conflict, the PLC or controller will always win. The cool thing about the ACN family of drives is you can tell the drive to only use the sequencer as the frequency source you want. That way, when the sequencer isn't running, the drive's normal logic can't take back control. Otherwise, the drive will resume whatever control of the frequency you set it up with when you tell the user sequencer to stop. So that's really important to remember. When the user sequencer is running, it always takes over whatever it's controlling. Okay, I did a lot of talking in that example. Let's do one more without all that talking so you can see how easy this really is. Let's take the frequency command and add 2 Hz and then add another 2 Hz to it once a second just so we can see how to connect blocks. Let's start a new project, give it a name, connect to the drive. Read in all the parameters. Again, I'll fast forward through that. Bring up the user sequence and the sequencer parameters, which again are really just empty memory locations for us to put stuff in. And let's do the side-by-side thing again. All the workspace stuff is still here. No problem. Double-click on the first guy and change it to an add. We got an error. Why? Well, we forgot to do the very first thing you always need to do. Make sure the sequencer isn't running, which ours is still running from the last demo. So I'll double-click on that, stop it, write it out. And I see that the drive got it, so we're good to go. Now if I double-click on the first block, I can change it to an add. The add sums all 3 inputs. Right-click to change input A to the command frequency, which is in the drives group, first parameter. We'll reuse these so there's no need to change them. We do need to change our values. We want to add 2 Hz, so I'll make user parameter 2 a 200. Again, 2 implied decimal places. Write that out. Arrow to user parameter 3 and change that to a 0. Write that out. We want the output to go to the next block, but we don't do that here. This output is only used if you need to also send the output someplace else. For now, I'll just 0 it out to get rid of the stuff left over from the previous example. In block 2, we want to add another 2 Hz. So double-click, add. Write that out. Again, keep an eye on this guy. We see it was written with no error. Perfect. Right-click and change input A to get from the user function's parameters block 1's output. and we see the connection line. We want to add another 2 Hz, so let's use parameter 10 for that just to be different. Change it to 200 for the 2 implied decimal places and write that out. Again, make sure it got written successfully. If it didn't, it's probably because the sequencer's running. If you leave the third parameter at 0, the block will just add the first 2. Let's switch to value display. Yep, exactly what we need. The 2 Hz is being added to the command frequency. This time we do want to modify the output because it needs to go someplace different. It needs to go to the drives group, command frequency. Now we want to add 4 Hz to the frequency command every second. So we go to the user parameters and change the loop time to 1 second. Write it out and double check that it actually got to the drive. Let's manually change the command frequency to 0 to make it easier to see the result. Now we just go to the sequence control parameter, change it to run, and write it out. And sure enough, the command frequency is changing 4 Hz every second. Perfect. Change the sequence control parameter to stop to halt the process. Well, that should be enough to give you a feel for how this works. Meanwhile, click here to learn more about the ACN family of drives. Click here to subscribe to our YouTube channel so you'll be notified when we publish more videos like this, and click here to learn about Automation Direct's free award-winning support options.